So here we go, students. Good evening, everybody. Okay, so I have flashed the first question on the board. I think it's visible, right? So please answer this. Which of the following substances possess highest elasticity? Quickly, everybody can shout the answer. Keep your mic on. Come on, you keep shouting your answers, then you will learn better. So those of you, Anushris, Prabhus, Aditis, Namans, okay, you are not at all speaking. Come on, this is an opportunity for you. Which has got highest elasticity?
Steel.
Why? Why? Why do you say steel has got highest elasticity? Come on.
Steel.
Steel. Why steel has got highest elasticity?
Sir, stress is directly proportional to strain for higher means elastic limit is higher.
No. Don't make any answer like that. How elastic limit is higher? How will it become more elastic? What is the science behind your answer?
Sir.
Yes, please. Somebody, see, you understand. See, I am asking you the concept of elasticity. See, concept. Yes, please.
Sir, the property of elasticity is to regain its original form the fastest than steel can get. Yes.
How steel can get back faster than other things? How do you know? Who told you that is the answer? No, sir, no. Simply, if you had read NCERT properly, you would have got the answer. See, listen now. Listen. See here.
Which can gain its original form.
No, that's see, if a body within elastic limits, see, if a body after being deformed by external forces, when the external, it should get deformed. See, there is a body, you apply external deforming forces, it will get deformed. Okay? Now, on the removal of external deforming forces, the body should try to return back to its original position. Then it is elastic. Correct? Hello?
Yes, sir.
Then it is elastic. If it does not have a tendency to regain its original shape, then we say it is plastic. Correct?
Yes, sir.
So this is how it is. Now coming to the concept of elasticity. Right? So this body is more elastic, this body is less elastic. How do you determine? So here you see the concept of stress will come into picture. The concept of stress will come into picture. Okay? So what is the concept of stress here? What is the concept of stress that will come here? Right? So what is stress? If you understand what is stress, then you can tell everything else. Come on, somebody tell me what is stress. Stress in a rigid body. Anybody? So you have come to this class with absolutely no preparation. Absolutely. Even the normal board examination also will be difficult for you. Leave aside CET, mains and all. I am making it very clear. Okay, you don't have the right attitude. Right? If you want to develop the right attitude, you will work for it. You are not working for it. Anyways, stress is what? See, when you have a body, see now, physics is very simple. You just have to imagine properly. Okay, so this is the imagination, right? So there is a body kept here. So its length is L. Now, if you apply force to this, what happens? This body will deform. Okay, so if you take this length, this deformation is dl on the application of force. This is precisely what happens. Now you see, when the body is deformed, it will develop internal forces. It will develop internal forces to oppose the external deforming forces. Correct?
Yes, sir.
These internal forces developed to oppose external deforming forces is called what? Stress.
Yes, sir.
Yes, sir. Eager. Now, how do you measure stress? You measure stress by taking the force at that point of time divided by the cross-section area. Cross-section area means it will be perpendicular. So this is how you measure stress. But what is stress? The internal forces developed to oppose external deforming forces. Correct?
Yes.
Now, coming to the concept of elasticity. A body which can develop a lot of stress forces. A body which can develop a lot of stress forces. That means it has got capacity to to oppose, it has got more capacity to oppose the deformation. Yet it is elastic. Yet it is elastic. That is important. That means now if you apply large deforming force, it will deform. And if you remove the deforming forces, it will again come back to its original shape, or at least try to come back to its original shape. But it needs lot compared to other things. See, for example, rubber. You take 1 meter rubber and you apply some force, it will deform by 1 centimeter. Okay. Same thing, you take 1 meter steel and if you want to deform it by 1 centimeter, you have to apply lots of force. Why? The steel can develop a lot of internal force to oppose the external deforming force. That is why steel is more elastic. Is that clear?
Yes, sir.
That is how you should learn. See, you are all solving problems in the college and you are simply applying formulas. So you have forgotten science. Okay, so don't do that. If you do that, you will be in for trouble in the final examination. Yes, please. What's your doubt?
That's yes, sir. It is defined when we are applying force to deform or after we have left the force and.
See the diagram here. Only when this external force is there, at that instant only this internal deforming forces are there. Internal deforming forces are there. Okay, so.
We have the external force.
If you leave the external force, it will come back to its original shape. It will try to come back to its original shape. That's it.
So that force.
No. That is not the way it is different. That is not the way it is different. So you are thinking that there is a force inside which will pull it back. That's what you are thinking.
Yes.
No, that is not the way to measure. That's not the way to measure. Okay. So it is. You see, you can understand this very simply. You apply physics. See, now this layer. You see this layer. For this layer, this layer contains what? Particles. So there is, at an instant of time, there is an external force acting. And this, even though there is external force acting, this layer, okay, is in equilibrium. That means there must be equal and opposite force acting on this. Hello?
Yes, sir.
And this internal force developed to oppose external deforming force under equilibrium condition is called stress. See, that is how you should learn these concepts properly. Okay? Anyways, you are a good boy, you ask question. Good. You please you can ask questions at the conceptual level. If you want clarity, I will give you. But on demand, because I don't have time to explain everything, because for each chapter I have just devoted 3 sessions. As you know, we don't have much time. Alright, so that is how you have to understand the concept of elasticity and explain it. Yes, please.
So we define stress before it is deformed or like.
Hey, why are you getting confused? See, why don't you understand this diagram? You have applied external force and the body is deformed and in equilibrium. At that instance, you are measuring the internal force which is opposing the external deforming force under equilibrium condition. That we call it as stress force, measured by force upon area.
Yes, sir.
Got it? Okay, done. Good. Okay, so the answer obviously is C. Alright. Go for this. The lower surface of a cube is fixed. Upper surface force is applied at 30 degrees from its surface. The change in its position. I am sure all of you would have started drawing the diagram. So it's a cube, right? So you will draw a decent diagram of a cube. There's nothing like indecent diagram, just telling you. Right. And the lower surface is fixed. Okay, so this is how we are going to make it. And now you are going to apply a force at 30 degrees, right? So with respect to the surface, you are going to apply a force of 30 degrees, right? So you are applying a force of 30 degrees, which is making an angle of 30 degrees. Right? Okay, so this is a force that is applied. Right, on the upper surface, so on the upper surface force is applied means it should be a distributed force. I am showing you as a pointed force, it can be a distributed force. Okay, at an angle of 30 degrees. Now, what will happen? Will shape change, size change, volume change, or both shape and size will change?
Both shape and size.
Both shape and
Yes, isn't it? Because you have to split this into two components, f cos theta, f sin theta. F sin theta, right? What will this f sin theta do? It will compress this. And what will f cos theta do? It will deform it. Isn't it? So f cos theta is going to shear. So you will get the shear stress. So the shape will change. It is a cube, it becomes a cuboid. Okay? Then as far as the vertical force is concerned, the size was so much, it will now become smaller than that. At least the height will become smaller. Got it? So therefore, both shape and size will change. Done. Shall I proceed? Any questions?
No, sir.
Come on. 2 meter log of radius 1 centimeter, which is fixed from one end, given a twist of 0.8 radian. The shear strain developed will be. Okay. So it's a rod which is twisted. Come on, think. I'll give you 5 minutes time. Think. If you don't know, you develop the required formula for this, and you should solve. Now, anybody is close to solving this problem?
Yes, sir.
Tell me.
I want confirmations.
Yes, please.
Sir, now if we are rotating it by some angle theta, sir, then it will like the twist will cover a length of r theta, sir, radius into theta, and that now since like it will be adding that much extra, like how much it is twisting, that much extra it is adding, sir. So can we say r theta by L as the strain, sir?
Something you are telling, your final formula seems to be correct, but what explanation you are giving is not right.
Okay, sir. Like
You are telling its length will increase by r theta. What do you mean?
So like when we are twisting it, sir, like that groove that is formed, so that twist which is there, sir, L equal to r theta. R theta will be nothing but the length of that arc.
No, what you said something will increase.
Yes, sir, that increase in the length will be r theta, no, sir.
But why did you take r theta by L is the strain? On what basis?
Strain will be change in the dimension upon original dimension.
So what is the original dimension?
The length of the rod, sir. 2 meter long rod. They are,
Okay, 2 meter length rod is the length of the rod. Now what is the change in the length of the rod?
By that angle which we are twisting, sir, it will create r theta arc, no, sir.
Gentlemen, see, I don't know how you are telling this, right? So you have a rod, right? You have a rod. Okay, you have a rod. Okay, so this is anchored. Now this end is okay. It's a circular thing. I agree. Now this length you have taken it as L. Okay, this length you have taken it as L. And
yes,
then, tell me, what is that? Which length will increase? You are telling.
Sir, when you twist it, sir, like the left hand side, that straight line boundary that you have drawn, sir, it will cross over the right hand side boundary, and right hand side boundary will cross over the left hand side.
ಅಷ್ಟೊಂದೆಲ್ಲ ಟ್ವಿಸ್ಟ್ ಮಾಡಂಗಿಲ್ಲ. ಅಷ್ಟೊಂದೆಲ್ಲ ಟ್ವಿಸ್ಟ್ ಮಾಡಂಗಿಲ್ಲ. ಸ್ವಲ್ಪ ಟ್ವಿಸ್ಟ್ ರೊಟೇಟಿಂಗ್ ಅಲ್ಲ ಅದು. ರಾಡ್ ಅನ್ನು ರೊಟೇಟ್ ಮಾಡಕ್ಕೆ ಬರ್ತೈತಿ. ಫಿಕ್ಸ್ಡ್ ಅದ ಅದು. It is just fixed. So this point A will now come here. So this point A, because you are giving a twist, you are giving a torque to this, because you are applying force in this direction. So this point A will come to A dash. So this is what will happen when you twist. You take something and twist, no. You take cloth and you twist. So you see my finger. My finger, I assume that it is holding the rod. This finger, it will twist. So this is all it will twist. See, you are writing the formula, but you are simply writing the formula. Because you have solved some similar to this. But you are telling some length will increase. And you told r theta by L. On what basis you are telling?
So that increase in length by the original length will be the strain.
Increase in the length is r theta. Okay, that's what you told. What is the original length?
The L
So
of
you-
the rod that originally they are given.
Which length? So you are telling this r theta is increasing the length. So what is r here?
Radius of the circular.
Okay, fine. Tell me, fine. So it is the radius of the circular ring. Fine. I'll take it. So this is the radius of the circular ring. That's what you are telling. Right? Okay. So this blue color line is the radius. Okay. And then it is making some angle theta. Right. This also everything. Then this is r theta. Agreed. A to A dash is r theta. Now what is the original length you are telling? Change in the length to original length. What is the original length?
The length of the rod.
How this length of the rod is L, and now the length of the rod will become L plus r theta. No, gentlemen, see, again you are doing something, you have solved similar problem using the formula. So you remember, oh, I solved that problem using that formula, I will use that formula. You are not understood that formula at all. See, don't do this, I am telling you, I want original, proper thinking, proper science. Okay, that's it you have to do. Now anybody is close to answering this? Hello? Okay, see, now please understand. Shear strain, correct? Hello?
Yes, sir.
Now you recollect what is given in NCERT textbook and what did you learn under the heading shear strain. Okay, the first diagram that will come to your mind is that, well, there was something like this kept, right? Okay, and its height was L, correct? And now you have applied force, which is you have applied force right, which is tangential to the surface, correct? I hope you remember this.
Yes, sir.
Then what happened? This body now deformed, correct? So this body now deformed. I hope you remember this diagram. Okay, and in the book it is very given. This point has moved to this point A has moved to this point A dash. And how much it is deformed? By L, by X. Hello? And then you have said this angle is theta. I hope you remember. Then what is the shear strain? Because shear means the force is parallel to the surface. Shear strain. So what is shear strain here? Shear strain is, it will be what? Shear strain will be, you see, the deformation has taken place in theta, correct? So that means now the shear strain will be, see, this deformation here is what? It is now X divided by L. This is what you have written. And this was equal to tan theta. And as theta tends to 0, because theta is very, very small, you can approximately write it as theta. I suppose all of you remember this?
Yes.
Change in this dimension to this. This is how you define shear. Hello?
Yes. Yes, sir.
Now go with this. Okay, you go with this. What has happened here? So you see, now I will take this point. So I will take this point as say some B. Okay, and I will, because now the original rod is like this. Okay, the original rod is like this, correct? Now you have twisted it, you are not rotated it. Somebody was using the term rotate or twisted it. So what happened? This point A, because you twisted, it has moved by A dash. It has moved to a new position, A dash. Okay. Now this point B will just get connected to this point B will get connected to A dash. Understood? So here our length is what we have used here. Length is also here also, this length is here. Okay, this length is also here. And what is the deformation here? A dash. What is A dash? If this radius is r and this is theta, A dash is nothing but r. This becomes what? This angle phi. Understand? This angle phi. Okay, so this angle becomes the shear strain. Is it clear?
Yes, sir.
See, that rod is twisted when, if you take a line, see, now if you imagine this rod, if you imagine this rod, okay, so what has happened? See, these points on the rod are fixed. This point was directly, I mean, if you take a line from this point to this point, this was a straight line. Now, because of the twist, this point A has moved to A dash, and so, but this point is fixed because one end is fixed, and therefore you join this. So, this line itself will make an angle phi. So, here you see this made theta, here it is making phi, and here we are taking this angle theta. So, therefore, we write it as r sin r theta by L. Is it clear? So, this is the shear strain for a rod. Correct?
Yes, sir.
So you should see students, I am telling you. Why I am telling you this, you please understand. See, in the textbook, this theory is here. Correct? You have understood that, you have solved problems on this. Now, there is a different situation. But the theory that you have developed here has to be used here. All that you have to do is, well, there is deformation. Here also there is deformation. And there is deformation here. Okay? Original length was here. This was also here. So, this is how you are going to get it. And here you are measuring this. Here you are measuring the twist in the angle. See, if you hold your hand like this and ask somebody to twist. See here, my hand is here, and supposing somebody has twisted. Can you see this point of mine? Hello? This knuckle of mine?
Yes, sir.
Now if I twist, what happened? This knuckle is in A, and supposing it is connected to this point, A is connected to this point, I twist it. So this point has gone from A to A dash, but this point is here only. So it is making an angle phi here. Correct?
Yes, yes.
Yes, sir.
So you see, you must use the signs, and in the situation you should be able to use that science, use that concept, and develop the formula. If you are able to do that, then you are doing justice to the process of learning science, and you are having the right knowledge. If you start recollecting the formula and then applying, then any person who has got very good memory, okay, he can also recollect and do it. That is not science. Anyways, shall I move on, students? So if you put all the values here, what will you get if you put the values? Hello? 2 meter, 1 centimeter. Hello?
0.00.
You should get 0.0 because that is 8 and 2 it gets divided. Only this option should be, you don't have to even calculate it. Okay?
Yes, sir.
See, this is how you should solve the numericals.